Hello there. Today in this video we're going to look at set complement. In our previous video we covered set union and set intersection, and we introduced what sets are. In this video we're going to talk about set complement. So to begin, the complement of a set A, denoted by A prime, we'll call it A complement, is the set of all elements under consideration that are not members of A. Thinking about this with a picture, let's just say that we have a set A and a set B, and we have our universal set. So here's our set A, here's our set B, and we have our universal set, which is the box on the outside. So in this instance, the complement of A is the set of all elements under consideration that are not members of A. So anything within this circle will not be included in A complement. Anything in this circle is left out, but everything else is included. So what I'll do is I'll use a different color to shade in everything that is actually included in the complement. Notice I'm shading the part of B that doesn't overlap with A, and I'm shading the part of the universe, the universal set, which is not a part of either A or B on the very outside. So notice I got the outside, on the outside of the circles, I got that colored in blue, and I've got the single part of B right here. So yeah, that's the complement of A in a Venn diagram. All of this will be filled in. Awesome. So that's the complement. Next, let's talk about, let's get into an example. So let's suppose that we have our universal set is the set 1, 2, 3, 4, and 5. And let's suppose that A here is the set 1, 2. So we're considering everything, all the integers between 1 and 5 inclusive. 1, 2, 3, 4, 5. And what we're going to do is we're going to write out what A complement is. Well, A complement is the set of all elements under consideration that are not members of A. So let's see, we got 1, 2, 3, 4, 5, and we got 1 and 2 are in A, right? So we only write the ones from the universe that are not a part of A. So we aren't going to write 1 and we aren't going to write 2, but we're going to write everything else in the universal set. So A complement will be the set 3, 4, 5. Again, just to reiterate, it's everything from the universal set that is not a part of A. Good. So we excluded 1 and 2 because they were a part of A. Next, let's suppose that our universal set is all integers. So integers look like this, you could have 0, 1, 2, 3, 4, 5, 6, 7, 8, it goes on forever counting upward. And then you can also count backward, 0, -1, -2, -3, -4, etc., counting forever to the left as well. So this is the integers notated with this, and the dot dot dots mean that it's going on forever. And the set A in this instance, we'll just say is the set of odd numbers. So we know that the integers are either odd or even, right? Or rather, a particular integer is either odd or even. So what we're doing here is we're considering all the integers, everything in this set right here actually, but we're throwing out odd numbers. So what do you think we're left with? If integers are simply either odd or even, but we throw out all the odd stuff, what's left over? Well, the answer is, since we're throwing out the odd stuff, what's left over is the set of even numbers. Cool. Well, that's a little bit more general example. Now let's cover what's called relative complement. So relative complement is actually really similar. It's also called set difference. It's really, really similar to set complement. So remember with set complement, we consider the universe, and then we throw out all the things that are in A. So we take our universe and we threw out the stuff that was in A, and that's what we were left over with. That's set complement. Well, relative complement, instead of working with your universal set, you'll work with, say, sets A and B. So A minus B is essentially the same exact idea as set complement. So anyway, so let's get into this example. So let's say that A is the set 2, 4, 6, 8, and 10. And let's say B is the set 1, 2, 3, 4, and 10. Now, what we want to do is we want to consider everything that's in A, but we throw out the stuff that's also in B. So let me say that one more time. We consider what's everything in A, 2, 4, 6, 8, 10. But we throw out what's also in B. All right. Well, let's take a look. So A minus B. Well, what's in common? Because whatever's in common in A and B, we're throwing out, right? So here we've got a 2, and here we've got a 2, right? So what I'll do is I'll actually just cross those out, because I know that's not going to be an A minus B. The next thing is we move on to the number 4. Well, 4 is also in B, right? 4 is in A, 4 is in B, so we cross that out. The next number in A is the number 6. Well, 6 is fine. 6 is not a part of B. 6 is a part of A, so 6 is in the set. It is in the relative complement. It is in the set difference of A and B. Next, we look at the number 8. 8 is, again, it's not in B, so we write it. And lastly, we'll consider 10. But 10, notice 10 is in both. 10 is in A, 10 is in B. So because of that, 10 will not be included in A minus B, right? So let's see what this looks like now with a Venn diagram. So basically, here's what we have. We've got the set A, we've got the set B, and remember what B contains. B contains the number 1. 1 is only in B, right? 2 is in both sets. 4 is also in both sets. 3 is in B only. 10 is in both sets. So, sorry, that's a little hard to read, but there's 2, 4, and 10 in the middle here. And then there's 1 and 3 on the outside. And let's see what's left over. Well, we've got a 6 and an 8. And that's it. 6 and 8. And those are only in A. So notice A minus B in this picture is actually just the part of A. I should have probably shaded in with a different color, but that's okay. You can still read through that, I hope. 6 and 8. These are the only things in A minus B. All right. Well, lastly, what I'd like to do is I'd like to look at one final big example just to kind of wrap everything up. We're going to look at unions, intersections, set complements, and we're going to look at relative complements here. We're going to compute each of those for the sets given in this example. Let's start with A union B. Well, A union B, remember what unions do. They take everything and they collect it all into a single set. So you take everything from A, everything from B, lump it all together. So we've got the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all from A, right? So we know we have to include those. Second, we've got the even numbers that come up here, right, in the set B. Well, 2, 4, 6, 8, and 10, those are already covered. But next, we've got the number 12, and the number 14, 16, 18, and 20. This is the union of A and B right here. Next, let's do the intersection. A intersect B. Remember, intersections are what is in common in the two sets. So let's see. We've got the number 2 in each, right? We've got the number 4. Notice the pattern. We've got the number 6. We've got the number 8. We've got the number 10. Those are the only numbers that are in common. And really, it's notice that the numbers that are in common here are the even integers between 2 and 10. We got 2, 4, 6, 8, and 10. So A intersect B is 2, 4, 6, 8, 10. Awesome. That's what's in common between A and B. All right, we've got 2 more to go. Well, I guess a few more. So we've got A complement to compute. So remember, A complement is the set of all elements under consideration that are not members of A. So we look at our universal set. The universal set is the numbers 1 through 20, right? And A is the set of numbers 1 through 10. So if we're considering everything in the universal set that's not an A, what we're going to do is we're going to throw out the numbers 1 through 10, and we're only going to consider the numbers 11 through 20. So I'll write that here. I'll write every number out rather than using ellipses, just to be as clear as possible. All right, awesome. So now we've got A complement. We can do the same thing with B complement. B complement is everything from the universal set that is not in B. So notice B is the even integers from 2 to 20. So we need to get everything else. We need to get the odd integers from 1 to 20. So writing those out now of 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and we don't write 20 because 20 is in B. Awesome. All right, so we've done union, we've done intersection, we've done set complements. Next, we can do set difference or relative complements. So relative meaning we're comparing A to B rather than with complements where we're considering a set to the universe. Here with the relative complement, we'll do A minus B first. A minus B is the set of stuff in A, but we throw out anything that appears in A that also appears in B. So we consider A, but we throw out the stuff that's in common between the two sets. So we know that A has we know that A is the numbers 1 through 10, and we know B has only even numbers, right? So we're going to write out all of the odd numbers here. 1, 3, 5, 7, 9, right? So we only write out the odd numbers in this list because the even numbers appear in B. But remember, when we're doing A minus B, it's like we're throwing out all the stuff from B that's also in A. Next, I guess lastly, we'll do B minus A, which won't be the same thing, right? So B minus A is the relative complement. B minus A, we consider all the elements of B, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and we throw out anything that's in common that's in A. Well, notice that the stuff that I circled is what's actually in common between these sets, right? The 2, the 4, the 6, the 8, and the 10. Well, I need to take everything from B that's not in common. So all the stuff that's circled in B, that's out because that stuff's already in A. So what I need is the 12, the 14, the 16, the 18, and the 20, because those are the elements that are in B that are not in A. Awesome. Well, Well, there's our big last example. I hope that this helped make things clear for you, and see you in the next video.